What's going on, guys? Johnny Bannon here with Trepa Technologies. And in today's lesson, we're going to be going over domain 1.4 in our Network Plus N10-009 course. The brand new Network Plus class, cert, as of August 23rd, 2024. So before we get started in the slides, we're going to do some hands-on today too. Let's go over the actual exam objectives that we are going to be covering in today's lesson. So let me zoom my face out here, put it off to the side. And let's go ahead and look at these exam objectives here. I'm going to zoom in just a little bit. So you see we're going to go over a bunch of protocols today. Secure, unsecure protocols. Then we got some internet protocol types we're going to go over. TCP, UDP, which if you've been watching this course in order with us, we've hit some of this stuff already, but we're going to repeat it. That's okay. It's CompTIA, is what it is. Let's go ahead and jump right into it. So, domain 1.4.1. Explain common networking ports, protocols, services, and traffic types. So you can see here our exam objectives, how we're going to start. And we got a lot to cover. So the first thing we're going to talk about is FTP. So FTP is a file transfer protocol service or protocol, or it's in the P, right? File transfer protocol. The whole purpose of it is to just transfer files from client to server, from client to client, from server to server. That's the entire purpose of FTP. Now, FTP uses TCP, which means that it has reliable communication. And it actually has two channels it's going to use. And with those two different channels, we have different port numbers. So one is a control channel running on TCP port 21. That's going to be the connection, right? That's going to be our initial connection to an FTP server from the client or from our FTP GUI. And then port 20 is going to be the actual transferring of that data, the actual data coming across it. So I'm going to actually try to open up FileZilla here. And I don't have like a VM running right now. Maybe I could pause the video and spin up VMware Fusion. I'm on a MacBook and like FTP into it. And I just might do that. But here's what an FTP server or application looks like, okay? And if I wanted to connect to another server via FTP, I could come up here, select my connections here, right? We have FTP, SFTP we're going to go over too. And the cool thing about FTP is you get this GUI. So you can actually control what files you want to send to the destination. Or really from local to remote site, but it goes both ways, right? So that's FTP. A little bit more robust than when we're going to talk about TFTP later on in this section. And I'm going to minimize this and maybe we'll pause the video and I'll show you guys how to transfer files via FTP or SFTP. Okay, SSH. So SSH is a network protocol used to establish a secure and encrypted connection. So SSH uses asymmetric encryption to establish terminal connections, line connections to servers, network devices from your SSH client. So the SSH client could be like your bash terminal in Linux, the terminal in Mac. You could be using a terminal emulation program like PuTTY or Secure CRT, and you can use SSH to get into the command line or the other bash terminals of servers and network devices. So let me bring up my terminal emulation program I like to use called Secure CRT. So with Secure CRT, I have some saved sessions here where I'm actually SSHing into a device, okay? So you can see here, this is my local switch. It's going to ask me if I want to use like a pub or private key to actually SSH in. I'm going to hit cancel here because I'm just going to use username or password. And this is my local office switch here, okay? So this program here, Secure CRT, I am SSHing into a network device. Now this could have well have been a server as well that I SSH into. But this is just a network device. And what it's allowing me to do for my local computer is to get into the command line of that distant device or that remote device. Okay? So I'm going to get out of here. Just want to show you. Now I can run commands. Show interface status. I'm using Stackwise on here. So this looks like a big switch, but it's not. I don't have 5 other blades. I forgot to turn Stackwise off. It's just a single blade. Anyways, that's a little bit beyond this section. So that's SSH. Now, what I'm going to show you here is how to set up SSH on a network device now. We come back here, you can see I have this topology. I'm using EVE-NG. EVE-NG running actually in a cloud VM in GCP. You can see that there. Okay, don't worry, those people watching this trying to hack my VM, that IP address changes, don't worry. But let's actually go in and set up SSH on a network device to actually show you some hands-on. So what we got going on here is we got these two routers. Already set up IP addressing between them. SSH is already set up on R1 over here. I'm going to set up SSH on R2 over here. And we're going to notice some things that we need to be configured prior to us actually generating RSA public and private key pairs, asymmetric encryption, to enable SSH on R2. So let's go ahead and do that configuration. So I got secure CRT up here. I'm going to head over to R2. This is my R2. I wish there was a clear button in the Cisco CLI, but it's not Linux. Okay, and I'm going to bring my face into view here because I'm going to clip this later. So let's go ahead and do this. So when we're setting up SSH on a network device, first we have to set up a host name. So we're going to do that. Next, we're going to set up a domain name. This is one of the requirements before we generate RSA keys. So if I try to generate RSA keys, crypto key generate RSA modulus 2048. These are my public-private key pairs, my asymmetric encryption that enables the SSH secure connection. It's going to say, please define a domain name first. So you can see the Cisco CLI is actually going to tell us. Now, other networking providers, it's not a Cisco exam, may have something similar. I just want to show you some fundamentals of SSH. Don't think that this is going to be a testable thing in a CompTIA exam. CCNA, for sure. Now I'm going to up arrow. Let's try to do that again. And boom, there we go. Now it's going to let me generate SSH keys. But another thing that we need is also a username and password. So I'm going to set that up. Username and password here. Again, Cisco CLI, don't get too wrapped into this. This just sets a permissions level, like a authorization level. And this just encrypts my password in the running config, okay? This is me setting a password of Cisco. The next thing we're going to do in a Cisco Catalyst device, this is what it's emulating. Oh, this is a router, actually, excuse me. This is like a 4K ISR, right? Is we have to set up and say transport input SSH on our VTY, our remote terminal lines. We're also going to put in login local here, saying login with the local credentials. We're going to head back to R1 over here. We're going to do a quick ping test to make sure we can hit the other side. There we go. We had one packet loss because we did address resolution protocol first. So IP ARP. There you go. We had to do ARP. Layer 3 to layer 2 mapping. We still got to do that on network devices. And when I want to SSH, I can do SSH TAC L, defining a username. And then I can go ahead and put the IP address. So now I'm SSHing between these devices in my emulated environment. And it's just going to lag on me, of course, because, you know, we're training. Set the password, and now from R1, we're in R2. So that is SSH. Now let's go back to the slides, get my face out of the center here, and let's continue. Okay, Telnet. So Telnet works exactly like SSH. Everything I just showed you, if we were in a Telnet session, it would look the exact same. It's just clear text, okay? So Telnet is just clear text, not secure when we're doing remote connections. Because if somebody's doing a packet capture like I got going on over here, they could see that unencrypted session in the Telnet commands coming across the wire. I have this Wireshark capture up here so we can go over HTTP later on in this slide. SMTP. This is a email protocol. The simple mail transfer protocol is used to send emails from a client to a server or between servers. So as you can see here, my little design I drew up, you can see that the sender here sending an email to its mail server using SMTP. Then that server sends that email to the recipient's mail server via SMTP. And then it uses IMAP or POP3. I should have wrote a POP3 there. My bad. To send it to the actual recipient. So that's what the simple mail transfer protocol does. And again, it works in conjunctions with things like IMAP and POP3. All right, SFTP. So SFTP is, again, a file transfer protocol, but unlike TFTP or FTP, it actually sends in ciphertext. So we're going to use SSH encryption, actually, those RSA or DSA key pairs, that asymmetric encryption, to establish a secure connection to do the file transfer protocols. So I'm actually going to pause the video. I'm going to spin up a VM right now, and we're going to do SFTP into that VM using something called FileZilla. Okay, so unpause the video. As you can see, I'm going to move my face back into here because I might want to clip this as well. You can see I got a VM spinned up. I got a Kali Linux VM running in VMware Fusion. I'm on a MacBook. You can see the IP addressing there. I'm going to minimize that now. And in our actual SFTP application, what I'm going to do, and this is FileZilla, I'm going to put the IP address there. As you can see, I've already done this. So IP address. I'm going to put the username, the password, and the port. Since I'm doing port 22, that's pretty much telling this application we're using SFTP, right? And I'm just going to do a quick connect. And boom, we're connected now. So as you can see, now if I wanted to move this file over here, let's see. If I want to move this this get parameters from DNAC Python file over here to the desktop. There it is right there. That simple, guys. And let's see if we had anything pop up in Wireshark. Let's see if we can... Actually, no, it won't show SSH, I don't think, because the VM is not... I'm doing the packet capture on my Wi-Fi NIC, so my bad. But still, we can actually see SSH here because I SSH'd that switch earlier. And you can see the SSH protocol. It's encrypting everything. Pretty cool. So let me minimize this stuff now, get back to our slides, move my face back out of the way, and let's continue. So DNS, the domain name system. So DNS is used every single day and you don't even know it. When you go to google.com, DNS is happening in the background, okay? So the domain name system, that is a service that's essential for communication on the internet, the interweb, the World Wide Web. And it does what's called host name to IP address resolution. So as you can see down here, the DNS architecture can be a little bit more complex. We have name servers, root servers, TLD servers. It can get complex. But at the end of the day, just for the Network Plus exam, you just got to know that, one, DNS in and of itself is insecure. There is no authentication built in natively to it. It's not encrypted. We can do it over HTTPS. We can add something called DNSSEC to make it secure. With authentication, that is, and non-repudiation. But all it does is host named IP address resolution in its base. And then it has additional things like MX records that you can put in, SPF and DMARC records to protect your email servers. It has pointer records that do kind of reverse pointer records. We have canonical name type records. And when you actually look at a DNS server, they all look a little bit different. We manage our DNS on Cloudflare. I've managed DNS for a big enterprise before, using sites and services in an Active Directory on-prem domain. I've done DNS records in Azure for our AZ-104 course. The GUI make look a little bit different, but DNS at the end of the day is just a long, almost like text file of records. We have A records that say, hey, this host name equals this IPv4 address. We have quad A records that say, hey, this host name equals this IPv6 address. We have canonical name records, right? That say, hey, www with the value goes to example.com. So we could hit this example.com using World Wide Web, or we can set up FTP for it. So that's DNS in a nutshell. If we come back, let me open up actually my Wireshark capture. Let's see if we can actually see DNS. So we can see some DNS queries here. We can see the flags, the queries, api.coinbase.com, looking for that A record. And let's see if we go in there. It's so funny what runs in the background. I have a Coinbase plugin running on Chrome, so I'm sure that's what this is. But anyways, you can see the A record here, okay? So api.coinbase.com. Pretty cool. We can see other ones here. Queries. My source, Canva. It's just pretty cool, right? Sorry, not get too lost in the weeds, but there's DNS. Okay, DHCP. Something else we're going to get some hands on here in a second, the dynamic host configuration protocol, control protocol. DHCP does one thing. It dynamically allocates IPv4 addresses to users, to clients. And that's its main purpose. IP address information as the client's IP, subnet mask, default gateway, as well as the DNS information. Now, it can do some, let's say, advanced configuration. We put options in there. Option 150 addresses. So our VoIP phones can reach out to their configuration server. Like Cisco VoIP phones need option 150 so they can reach out to the call manager via TFTP to get their phone profile. We can do things like option 66, 67 for pre-execution environments where we actually image computers over the LAN. But at the end of the day, DHCP does one simple thing, and that's dynamically allocate IP addresses to users that request it. DHCP, the best way to know its operation is to remember an acronym called DORA, Discover, Offer, Request, Acknowledge, where the discover and request messages are broadcasted from the client saying, hey, I need IP addressing, and the offer and acknowledge messages being unicast messages from the server offering an IP address and acknowledging that the client got that IP addressing. Okay? Port 67 is used for the clients. Port 68 is used for the servers. Now, I'm going to show you how to configure DHCP on Cisco iOS. I got a virtual PC running in my EVE-NG environment, and we are going to configure it and see if our computer can pull an IP address. So I'm going to come back here. I'm going to gig 01's already configured with the default gateway. And then this PC, we're going to have get IP addressing via DHCP. But first, let's go ahead and configure R2. And again, I'm going to bring my face over here because I'm going to potentially clip this, put it on the Instagram, this other social medias. All right. So if we want to set up a DHCP, this iOS is a DHCP server, we got to create a DHCP pool and name it. This is for our Net Plus class. So from the Cisco's iOS CLI and global config mode, we're going to make a DHCP pool. Next, we're going to say what is the network address for this DHCP pool with the CIDR. And I may need a space here. And then we're going to say default router, which means what is the default gateway? It's going to be 10.1. We're going to set up some DNS servers, our primary and our secondary. Google, and I think 9 is Cloudflare, I'm pretty sure. Or is it just Google? Can't remember. Doesn't matter. And that's going to be our basic setup. If we want to do some exclusions, IP DHCP excluded address, we could say, hey, 192.168.10.50 through 192.168.10.100 are going to be excluded because that's going to be for our servers, VTC machines, file shares, printers, things like that. We can do that. Now that it's set up, let's test this out, guys. I'm going to type in IP DHCP here. And what's cool about these virtual PCs in the EVE-NG environment is you can actually see it do the DORA request. So it looks like it's not going to get it. So let's do some troubleshooting. Let me make sure that this interface is configured correctly. Do show on interface gig 01. It's shut, of course. So we're going to go ahead and no shut that. We're going to turn that port on. And now let's do our DHCP request. So we're going to send that discover message. And then we got our offer request acknowledge. And boom, we got IP addressing now. Awesome. I don't know how to do it, like if it's show IP. Yeah, there we go. And we see we got the DNS, we got the DHCP server, the gateway, and our IP with the subnet mask. Great. Now let's go back to the slides. And let me get my face out of the way and minimize it. Okay, TFTP, the Trivial File Transfer Protocol, does the same exact thing as the other file transfer protocols we've been learning about, except it's trivial. Well, what does that mean? It just means it's UDP, okay? Built into the actual application TFTP are some checks, though. You can see here, I drew up this nice little diagram, handmade by me, right, guys? No, it's Canva. But there are checks, right, where we can see how many bytes were sent and how many we received. But it is UDP. There is no security. In networking, it's used very commonly to search for iOSs. When like a Cisco router boots up, if there's not an iOS in its storage, its flash, it'll look via TFTP. We can send iOSs to Cisco devices using TFTP. It's used a lot. It still has use cases, but it differs from FTP in that it's technically it's unreliable because it uses UDP. There's still checks within the protocol itself, but like FTP, it's not secure, and there is no secure version for TFTP. Okay, Hypertext Transfer Protocol. This is what's used to get web pages, guys. HTTP and HTTP requests and the verbs get, post, put, they are what interact, those messages interact with the web server so that we can pull down a web page and I'll put it onto our browser. When I go to HTTPS, right, trepatech.com, I'm sending HTTP requests to my web server to pull down HTML files so I can render a web page. Now, HTTP is not secure. It's plain text. You can see inside a HTTP message, what I'm about to show you in Wireshark, because I'm going to my EVE-NG environment in the cloud via HTTP. It's not secure, okay? It uses port 80. It's unsecure. But the Hypertext Transfer Protocol, it's what we use to pull down web pages. It is what makes the internet happen, as I like to say, because without it, we would not be rendering any web pages, and the internet would be not very useful for a lot of us, okay? So let's go check out how insecure it is. Insecure, right? Insecure protocol. Has trauma, childhood trauma. All right, so let me look up HTTP. You can see here the HTTP GET messages. So those GET verbs, that's doing a read operation, essentially saying, hey, I want to see this. I want to see this info, API labs, my Network Plus demo labs in my EVE-NG environment, okay? So put my face in here. I may want to clip this as well. I know I'm internet brained right now. But we can see here, we look into this like request here. We can actually look inside this HTTP and see the full request. See where we're heading to. A lot of these headers here. We can see the user agent. So this is, me. So as you can see, if this was how the internet ran, we would be vulnerable to a lot of stuff, guys. Luckily for us, all internet traffic should be HTTPS. This is a weird environment I got going on where this EVE-NG VM and Google Cloud has to run via HTTP. It can't really do SSL certificates on the actual VM. Anyways, but it's a great example to see and look inside this HTTP request. We can actually see the cookie here. We can see in this GET request here what it's actually looking for. We can see in this URI query. So we can get a lot of information and we can kind of see what HTTP is doing here on the wire. Awesome. Let's go ahead and go back to our slides, because I think we're close to done, and then we can do our quiz. Okay, last thing we're going to talk about, the network time protocol. So the network time protocol is used to synchronize clocks. It starts at NTP, the network time protocol, is used to synchronize times throughout our enterprise, on our servers, on our network devices, and we need that for a lot of different reasons. One off the top of my head, Kerberos, to actually, put servers, put clients, put objects in an Active Directory domain, we need synchronized timing. We need synchronized timing for things like GPS, talking about satellite communication. Maybe we need synchronized timing on our routers and our network devices because we're deploying WAN keys with time to lives. And not TTLs. What I mean by that is send and accept lifetimes, where we say, hey, this WAN key is good from June to December 2024. After that, we got to rotate that. So our router has to be synchronized. The clock has to be accurate. We can do that with NTP. NTP uses port 123, and Stratum 0 is going to be the most accurate, that atomic timing, and then every hop away from Stratum 0, it increments by 1, and the higher up you go in Stratum levels, the less accurate the timing is. All right, let's go ahead and do our quiz. All right, so domain 1.4.1 quiz. Question 1. Which protocol provides secure file transfers and operates over port 22? I'm going to go with SFTP here. And there we go. Question 2. Which protocol is used to send emails and operates on port 25? That's going to be the Simple Mail Transfer Protocol, SMTP. Question 3. Which protocol is used for transferring files without the need for authentication and operates on port 69? That's TFTP, because remember, FTP has that control channel, which makes you like use username and passwords to then use FTP, so you gotta authenticate. So TFTP, port 69, and you don't need authentication for it. Which of the following ports is used for FTP for data transfer? This is tricky. Remember, FTP has 2 ports. Port 21 is for control, and I believe port 20 is for data. We're about to see, and there we go. Port 20 is used to send data, the actual transfer of the files. Which protocol is essential for synchronizing clocks across devices on a network and operates on port 123, 123? That's the network time protocol. Question 6. When you type a web address, like www.example.com, in a browser, which protocol is responsible for resolving this address to an IP address? Well, that's going to be the domain name system or services, right? Host name to IP address resolution is exactly what DNS does. Question 7. Which of the following is a primary reason for using SSH instead of Telnet? Well, guys, I mean, let's... the obvious. It's secure. SSH is encrypted. And last question. Which of the following ports is used by DHCP to assign IP address devices on a client? So ports, so that kind of narrows it down already, right? We have good comprehension of the English language. But that's port 67, 68. And we are at 100%. Awesome, guys. So I want to thank everyone for viewing. Smash that like button, smash that subscribe button, and turn on that bell. And stay tuned for our next video. We finish up Domain 1.4.